Evaluate your experience and qualifications realistically, especially considering your background is not primarily in commercial electrical work. A 1000 amp commercial building is a complex and potentially hazardous project. Weigh the potential risks carefully and determine if your qualifications adequately prepare you for it. Consult with experienced electricians, electrical engineers, or certification organizations to gain insights and assess your readiness for this specific task. If you decide to attempt the project, firstly, obtain proper instruction through training courses, workshops, or mentorship from qualified professionals. Secondly, gather all necessary resources, ensuring you have the right tools, materials, and required safety equipment. Thirdly, develop a detailed plan and strictly adhere to all applicable codes and standards. Fourthly, consider hiring licensed electricians to assist with tasks that exceed your current skill level. Fifthly, stay up to date with the latest advancements in electrical technology and industry best practices. If you decide to pass up the project, firstly, refer the client to a reputable electrical contractor capable of performing the work safely and effectively. Secondly, continue your education by pursuing additional training and certifications to enhance your skills and prepare for future opportunities. Thirdly, maintain your existing knowledge, staying abreast of current electrical standards and best practices. Family support and a strong desire to succeed can be motivating, but should not compromise safety or professional judgment. When in doubt, passing up the project is a responsible decision that protects both your reputation and safety. Seek mentorship and support from experienced professionals in the electrical field to guide your career growth. Regarding your Mike Holtz Master Electrician exam preparation, use it to reinforce your knowledge, especially focusing on commercial applications and current updates relevant to your location and the project type. Also, consider taking continuing education courses focusing on the 2023 National Electrical Code, which is the latest version. Study Articles 210, 215, 220, 225, 230, 240, 250, 300, 310, 312, 314, 330, 334, 344, 348, 350, 352, 356, 358, 360, 362, 366, 368, 370, 374, 376, 380, 382, 384, 386, 388, 390, 392, 394, 396, 398, 400, 402, 404, 406, 408, 410, 411, 422, 424, 430, 440, 445, 450, 455, 460, 470, 480, 490, 500 through 517, 518, 520, 525, 530, 540, 545, 547, 550, 551, 552, 553, 555, 600, 604, 605, 610, 620, 625, 626, 630, 640, 645, 646, 647, 650, 660, 665, 668, 669, 670, 675, 680, 682, 685, 690, 691, 692, 694, 695, 700, 701, 702, 705, 708, 710, 720, 725, 727, 760, 770, 800, 805, 810, 820, 830, 840, and 900, as well as the associated tables and examples. Focus especially on sections regarding service calculations, overcurrent protection, grounding and bonding, wiring methods, and equipment specific to commercial installations. When dealing with a 1000 amp service, ensure you understand the requirements for service entrance conductors, overcurrent protection devices like fuses or circuit breakers, and the grounding electrode system. Article 230.42 details ampacity requirements for service entrance conductors based on the calculated load. Article 240 covers overcurrent protection, ensuring the service is protected against overloads and short circuits with properly sized fuses or circuit breakers. Article 250 is crucial for grounding and bonding, ensuring a low impedance path for fault currents to safely clear. This includes bonding the service equipment, grounding electrode conductor sizing, and bonding of metallic components. Wiring methods for commercial buildings often involve conduit systems like rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. Articles 344, 342, and 348 respectively cover these methods, detailing installation requirements, support, and allowable uses. Boxes and enclosures, covered in Article 314, must be appropriately sized for conductor fill and provide proper protection for connections. Conductors must be selected based on ampacity, voltage drop, and environmental conditions. Table 310.16 provides ampacity ratings for various conductor types under specific conditions, while Article 310.15 addresses correction and adjustment factors for ambient temperature and the number of conductors in a raceway. Understanding load calculations is critical for sizing the service and feeders. Article 220 provides the methods for calculating branch circuit, feeder, and service loads, including demand factors for various types of occupancies and equipment. Commercial buildings often have specific requirements for lighting, receptacle outlets, and HVAC systems, which must be factored into the load calculations. Emergency systems, covered in Article 700, require a separate power source and transfer equipment to ensure continued operation during a power outage. These systems must be designed and installed according to specific requirements for reliability and performance. Healthcare facilities, covered in Article 517, have stringent requirements for electrical systems to ensure patient safety. These include essential electrical systems, isolated power systems, and grounding requirements. Hazardous locations, covered in Articles 500 through 517, require explosion-proof or intrinsically safe equipment and wiring methods to prevent ignition of flammable gases or vapors. Carefully review the specific requirements for the classification of hazardous locations present in the building. The 2023 National Electrical Code includes updates and revisions that could affect the installation. Be sure to check for local amendments or interpretations that may apply in your jurisdiction. For example, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air based on ambient air temperature. Adjustments must be made based on the number of current carrying conductors in a raceway or cable, as well as the ambient temperature. Example: a 100 amp overcurrent protection device requires conductors with an ampacity of at least 100 amps before any dirting or correction factors are applied. If the ambient temperature is higher than 30 degrees Celsius, or if there are more than 3 current carrying conductors in a raceway, the ampacity must be adjusted accordingly. In commercial buildings, you'll often encounter 277/480 volt or 120/208 volt systems. Understanding the phase relationships and voltage characteristics is essential for proper wiring and equipment selection. A 277/480 volt system is a 3-phase, 4-wire system with 277 volts from each phase to neutral and 480 volts between phases. A 120/208 volt system is also a 3-phase, 4-wire system with 120 volts from each phase to neutral and 208 volts between phases. Single-phase loads can be connected to either system, but three-phase loads require a three-phase supply. When working with large commercial services, coordination studies are crucial to ensure selective tripping of overcurrent devices. A coordination study involves analyzing the time current characteristics of all overcurrent devices in the system to ensure that the device closest to the fault opens first, minimizing the extent of the outage. Ground fault protection of equipment is required for services rated 1000 amps or more. This protection is designed to detect low-level ground faults and trip the service disconnecting means, preventing damage to equipment and reducing the risk of electrical shock. The maximum setting for the ground fault protection is typically 1200 amps and the maximum time delay is 1 second. Surge protection is becoming increasingly important in commercial buildings to protect sensitive electronic equipment from voltage transients. Surge protective devices should be installed at the service entrance and at downstream panels to provide comprehensive protection. The selection and installation of surge protective devices should comply with Article 285. Consider a scenario where you have a 480-volt, three-phase motor with a full load current of 100 amps. According to the 2023 National Electrical Code, the minimum conductor ampacity would be 125 amps, which is 125% of the motor's full load current, as per 430.22. The overload protection device, such as an overload relay, should be sized no larger than 125% of the motor's full load current for motors with a service factor of 1.15 or greater, or a temperature rise of not more than 40 degrees Celsius, as per 430.32. The branch circuit, short circuit, and ground fault protective device, such as a circuit breaker, should be sized according to 430.52, typically not exceeding 250% of the motor's full load current for inverse timed circuit breakers. Remember to consult the motor's nameplate and the relevant tables in Article 430 for specific requirement. If the commercial building includes a transformer, proper overcurrent protection is essential to prevent damage from overloads and short circuits. Primary side overcurrent protection should be sized according to 450.3, typically not exceeding 125% of the transformer's rated primary current for transformers with impedance not more than 6%. Secondary side overcurrent protection should also be provided, size according to the transformer's rated secondary current. If the transformer is located in a readily accessible location, it may require additional protection, such as a thermal overload switch. Understanding the National Electrical Code requirements for fire alarm systems is also critical in commercial buildings. Fire alarm systems must be installed according to Article 760 and must be properly supervised and maintained. The fire alarm control panel must be connected to a reliable power source and must have a secondary power source, such as batteries, to ensure continued operation during a power outage. Smoke detectors must be installed in accordance with the building codes and must be interconnected to the fire alarm system. Regular inspections and testing of the fire alarm system are essential to ensure its proper operation. Commercial buildings often have complex lighting systems, including fluorescent, LED, and high-intensity discharge lighting. Understanding the requirements for ballast wiring, lamp replacement, and energy efficiency is important for maintaining the lighting system. Ballast must be properly matched to the lamps and must be replaced when they fail. LED lighting is becoming increasingly popular due to its energy efficiency and long life. High-intensity discharge lighting, such as metal halide and high-pressure sodium, is often used for outdoor lighting and in high bay areas. Remember to consider voltage drop in long circuit runs to ensure that equipment receives adequate voltage. Voltage drop can be calculated using Ohm's law and the conductor's resistance. The National Electrical Code recommends limiting voltage drop to 3% on branch circuits and 5% on feeders. To minimize voltage drop, use larger conductors or reduce the circuit length. Always use proper personal protective equipment, including safety glasses, gloves, and insulated tools when working on electrical systems. Follow lockout/tagout procedures to energize circuits before working on them. Be aware of the potential hazards of arc flash and take appropriate precautions to protect yourself. If you are not comfortable working on a particular electrical system, it is best to call a qualified electrician. Article 110.16 requires arc flash hazard warnings on electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. The warning labels must include the nominal voltage, arc flash boundary, and personal protective equipment requirements. Conducting an arc flash risk assessment is essential to determine the appropriate level of personal protective equipment. Regarding bonding and grounding, ensure that all metallic components of the electrical system are properly bonded together and grounded to a common grounding electrode system. This includes bonding metal conduit, metal enclosures, and metal equipment frames. The grounding electrode system should consist of a grounding electrode conductor connected to a grounding electrode, such as a ground rod, a metal water pipe, or a concrete encased electrode. The size of the grounding electrode conductor should be based on the size of the service entrance conductors, as specified in Table 250.66. Remember to properly torque all electrical connections to ensure a reliable and safe connection. Loose connections can cause overheating and arcing, which can lead to fires. Use a calibrated torque wrench to tighten connections to the manufacturer's specified torque values. Inspect connections regularly for signs of loosening or corrosion. Use an appropriate antioxidant compound on aluminum connections to prevent corrosion. If you encounter any unfamiliar or complex electrical systems, do not hesitate to seek assistance from a qualified electrician or electrical engineer. It is always better to be safe than sorry when working with electricity. Review the relevant sections of the 2023 National Electrical Code and any applicable local codes and regulations. Attend continuing education courses to stay up to date on the latest electrical codes and best practices. Network with other electricians and electrical professionals to share knowledge and experiences. Remember, taking on a 1000 amp commercial project requires a thorough understanding of electrical codes, safety practices, and industry standards. If you have any doubts about your ability to safely and competently complete the project, it is best to pass it up and refer it to a qualified electrical contractor.